Autoclave Engineers is dedicated to solving routine and difficult problems by offering precision-engineered and manufactured premium quality products. This commitment to excellence has contributed to making autoclave fluid components the world's largest supplier of high-pressure valves, fittings, and tubing. Recognizing that any product must be assembled and installed properly in order to function efficiently, Autoclave presents this demonstration to show the correct procedure for coning and threading tubing for medium and high-pressure valve and fitting connections. Please note that Autoclave engineers recommend safety glasses be worn at all times during coning and threading operations. For manual coning and threading, you'll need the following tools: collet wrench, included with the coning tool, a file, tape measure, hacksaw, a reamer, and Autoclave's coning and threading tool set. In addition, you'll need medium weight cutting oil with a high sulfur content and a cleaning solvent. We offer cutting oil designed specifically for use with coning and threading tools. For this demonstration, we'll cone and thread 1/4 inch OD high pressure tubing with an M250C connection rated at 60,000 psi. The first step is to determine the length of tubing. It's important to allow extra length for proper engagement with the connection. Table 1 shows the allowance required for the various connection types available. Once the length has been determined, add 1/8 inch. This provides for the 1/16 inch necessary on each end for facing in the coning procedure. As you can see, there are 4 inches between the outside faces of connection A and B. Both connection types are F250C, therefore add 1 inch for the engagement of both ends and an 1/8 inch for facing the tubing. The total length required then is 5 1/8 inch. Placing the unused portion of the tubing in a vise, cut to length with a hacksaw. Always use a vise with soft jaws so you don't score the tube. Put the tube into the vise and use a file to prep the end of the tube. Round the edges, removing all burrs so the tube will slide easily through the coning tool. Once the tube is filed, it's ready for coning. Before proceeding, the coning tool feed nut must be adjusted to accept the size and type of tubing used. Table 2 shows the various sizes of medium and high pressure tubing with corresponding dimensions for the finished cone dimensions. Disassemble the coning tool. Here's the blade holder and the tube holder. There's only about 0.02 clearance between the two, so the coning action will be centered and concentric with the tube. The tool should assemble and disassemble easily. This piece actually holds the tube. It's a collet and collet nut assembly. When these pieces are assembled, the tube slides through the collet nut assembly. The position of the tubing in the window of the coning tool indicates the time to start coning. The tube should be flush with the upper edge on the window. Tighten the collet nut to hold the tube firmly without leaving marks or scoring. These cutting blades with the coning tool are angled. When inserted properly, you should have one angle going in this direction and one in this direction. If the blades are backwards, they won't cone the tube properly. Assemble the tool, insert the cutter support, and tighten the feed nut finger tight, then back off slightly. Lubrication is critical to the coning operation and should be used freely throughout. The feed nut must be rotated at a different speed than the cutter handle. There should be a gradual feed of the nut. Feeding too fast will make the tool bind. Feed the nut slowly while turning the handle. The approximate depth of the cone for this particular size tubing is 1/8 inch. Again, make sure the tool is well lubricated. If the process is too fast, smoke will appear. Continue this process until the cone is complete. When you're at the end of the cone, you'll notice there's a slight difference in the pressure of the cutting action, which indicates you're facing the tube. Once you notice the difference in pressure, keep the feed nut secure and rotate the cutter handle approximately 5 turns. After 5 turns, keep rotating the cutter handle and back off the feed nut. It's important to keep the handle rotating in the same direction, which prevents any horizontal or vertical scoring on the cone area, where the seal is formed. Remove the tool and wash the chips from the tool using mineral spirits or another safety solvent. A hand brush may be required to assist in removing chips. Loosen the collet nut and the tube will release. The finished cone should look like this. Notice the taper on the end of the tube. Next, make sure the tool is clean and place it in the tool from the opposite direction. Tighten the collet nut to lock the tube in place. Position the tool in the vise so the cutting oil can be easily applied. This is an autoclave threading tool. Notice there's a guide bushing at the bottom which helps you to align the tubing to start the first thread. Place the threading tool over the tube and lubricate. This will be a left-hand thread, so start at a left-hand counterclockwise motion. Push down on the center of the tool and rotate one turn. Then release and make approximately 12 more turns. Every few turns, or when required to break the material chips, rotate back like this. Of course, make sure the tool remains full of lubricant while cutting. After completing approximately 12 turns, back off the tool by reversing the direction of the handle. When you get to the last thread, a spinning motion breaks off the chip, allowing you to remove the tool easily. Using a reamer, deburr the inside of the tubing. This prevents chips from entering the connection following makeup. The cone and thread length can be easily checked using the cone and thread gauge. This M250C connection for 1/4-inch high-pressure tubing is representative of all coned and threaded type connections. Next, we'll place the collar and gland assembly on the tube. This is a high-pressure collar and gland assembly. Place the gland on the tube. Note the collar has left-handed threads. Lubricate the gland threads with a metal-based lubricant. Operating temperature may affect which lubricants can be used. Screw the collar down until there's approximately 1.5 threads exposed above the collar to ensure proper sealing when the connection is torqued down. The connection is now ready for makeup with an autoclave high-pressure valve or fitting. This particular connection requires a torque of 25 foot-pounds and is rated at 60,000 psi. Now let's review the several key steps in the manual coning and threading operation. 1. Determine the tube length and cut to size. 2. Insert tube into holder to top edge of the window and tighten. 3. Adjust feed nut on the coning tool. 4. Insert cutter support with blades into housing. Rotate cutter handle and feed nut. 5. Reverse tube position, attach threading tool and cut threads. 6. Deburr tube. Accurately coned and threaded tubing is an important element in maximizing the efficiency and safety of these valves. We hope this video helps you in the makeup of low, medium, and high pressure valve and fitting connections.